Hello, this is Mr. Huff, and this is a quick lecture about forces and flight stability. So when you look at an aircraft, there are four forces in play. You have lift, thrust, weight, and drag. Weight is sometimes referred to as the force of gravity. Here is a little more information about those four forces. Weight is a gravitational attraction from the Earth. Lift is created by the airflow over and under the wing. Thrust is produced by the power plant or the engine. And drag it's kind of like friction. It's from the air. So we'll get more into atmosphere later, but the thinner the air is, the less drag there is. A force is a vector quantity, which means it has a magnitude, or how much, and a direction. Usually when we're drawing diagrams of forces, the length of the arrow indicates the magnitude and the direction of the arrow indicates the direction of the force. So this helpful animation demonstrates how to find the sum of forces. If you have two opposing forces, you subtract the two, and that's how you find the total force. So in this case, you have 40 newtons of force going to the left, 75 newtons of force going to the right. You subtract 40 from 75, you get that there is a total force of 75 newtons to the right. This diagram shows the same idea. So in this case, what would the resultant force be? So when the forces are equal and opposite, then they are at equilibrium. So the net force is zero, and it's called static equilibrium. So that means that if the object is moving, it is moving at a constant velocity. It's not accelerating, nor is it slowing down. So in order for this aircraft to move from point A to point B, you have to have a thrust. It has to have some force causing it to go from the right side to the left. As it's moving, it experiences an opposition in drag. So drag is what slows it down. So if you turn the engine off, if the engine's pulling it forward and you turn that off, the drag will immediately start to slow the aircraft down. So when thrust and drag are equal, that means that the aircraft is going to remain flying at a constant velocity. To increase acceleration, you either have to increase thrust or decrease drag or reduce the mass. Weight is also acting on the aircraft. It's the force of gravity moving downward. So now we need to talk about weight and balance. For every aircraft, the manufacturer determines a zone or an area where the center of gravity needs to be. It can be a little to the front, a little to the back, but there's a specific place where it needs to be in order to keep everyone safe. If it's inside the range determined by the manufacturer, the aircraft is easy to control. If it's outside of that range, flying that aircraft becomes unsafe. So this is something that has to be determined before you fly. It's part of the pre-flight checklist. Pre-flight. Ugh. In order to complete this calculation, we need to measure everything from a datum line, and that datum line is usually set at the firewall behind the engine. Things that have to be accounted for: the weight of the aircraft, the pilot or pilots and passenger or passengers, any cargo, and any fuel. We need to recall how to calculate moment. Moment is force times distance, and we're going to presume that the force is applied perpendicular to the distance. So to reduce this, m is equal to F times d. That's the terms. So the distance between the point of rotation and where the force is applied is our distance. The line of action needs to be perpendicular to that line. If it is an angle, then you have to do some trig. So this is how you calculate the balance. And we're going to be calculating in a very bizarre unit, inch pounds. Okay, so here's what you do. You make this table where you have the item, the weight of the object, which is going to be the force, and those of you who have had physics, force and weight are kind of different ideas, but in this case we just need to know the weight. So we're looking at pounds and inches. That's the units we're working with, so we'll go with that. So we need to have a table that looks like this, the item, the weight of each item and the distance from the datum in inches. So we're measuring everything from here, and we're going to calculate the moment for each item using force times distance. So we're going to multiply these two together, and then we're going to total the weight, and we're going to total the moment. Okay, so we add up all the numbers in this column, we multiply these two numbers across and write those values down, and then add up the numbers in this column. So we end up with 2,400 pounds and a moment of 104,000. We need to take these two numbers and go find out if it's safe to fly the aircraft or not. So this is from the pilot's handbook. So let's figure out if it's safe. So we have weight over here and the moments across the bottom. So we look at our weight is 2,400 pounds. We kind of follow that line across here, and we go down here, and we know it's 104,000 inch-pounds. So we go across here, and we draw the line that intersects there, and it puts us right on the red. Let's talk about this real quick. This is the center of gravity moment envelope, and if you've ever heard the term pushing the envelope, that means that your results end up on this red line. If it's inside this area, then the aircraft is safe to fly. If it's outside of this zone, then it's not safe to fly. So right here, we would see that our aircraft is safe to fly, but just barely. It's pushing the envelope. And that's all we're going to talk about for today. Thank you so much for listening.